Assalamu alaikum warahmatullahi wabarakatuh. Good morning everybody. Today we will start chapter 6, limits and continuity. We will learn how to calculate the limits for the function for multivariable, for two variables. But first we have to revise the limits for the function of one variable. We have to revise how we calculate the limit if I have a function of one variable. Y is equal to f of x. Yes, so usually when I have a function of one variable, y is equal to f of x, we calculate the limit from the right, from the left, and calculate the limit of the right. If the two limits are equal, then the limit exists. If the two limits are not equal, then the limit does not exist. For example, if I have a log for this function is one variable of x, so this function at 0, if I have this point at 0, the function does not exist. At 0, the function does not exist. Or here, here, the function does not exist. Why? Because if I calculate the limit of h of x when x goes to 0 from left, when I goes to 0 from left, from here, then you will find that the function goes to 1. The function goes to 1. When you come to the 0 from the left, then the function goes to 1. Okay, what about if I come to the function to the 0 from right? So if I need to calculate the limit when I come to the 0 from right, then we will find that the function come to -1. The function itself goes to -1, not for 1. So here, this is -1, this is 1. Here we have the limit does not exist. The limit is different. The limit from left is 1, while the limit from the right is -1, which means that the limit is different. So in this case, we said that the limit does not exist. We say that limit does not exist. Okay, now if you have a log for this point, for example, x equal to 2, if I calculate the limit of h of x when x goes to 2 from left first, if I go to the 2 from left here, then the function goes to 3. The function goes to 3. If you come to the 2 from right, x goes to the 2 from right, then the function goes also to 3. So here the limit from left is equal to the limit for right, and which is equal to 3. So when I calculate the limit when h of x goes to 2, then f of x or h of x goes to 3. So the limit exists. But for 0, when x goes to 0, the limit does not exist, because from the left it goes to 1, from the right it goes to -1. So we have different limit from the left and from the right. So we said that the limit does not exist. So if I have a function of one variable, y is equal to h of x. X here is one variable only. What about if I have a function of two variables? The function of two variables. The idea is similar, but with a little bit difference. Let us look here. If I have a function of two variables, f of x goes to L. Okay, and I need to calculate the limit for the function when xy goes to AB. Now I have not only one variable, x goes to a or x goes to 0. I have two variables, xy goes to the point AB. So what about the limit? What is the limit equal to what? The limit equal to what? Actually, if the limit from all sides equal to one value, then we said that the limit is equal to L. But if I can choose two different paths with two different limits, then we can say that the limit does not exist. So if we have a look for this function, for function of two variables, to say that the function of the two variable exists, we have to calculate the limit from all paths as we did for one variable. For one variable, when we said that the limit exists, we calculate from the right and from the left. For in the case of one variable, we have only two paths, from the right, from the left. If they are equal, then the limit exists. If they are not equal, the limit does not exist. Similar idea or similar principle for limits and continuity of two functions. You have to calculate the limit from all paths. If it is equal, then the limit is equal to L. If I can find two paths rule or two paths that the limit from the first path is equal to the L1, the limit from the second path is equal to L2, then the limit does not exist. For example, if I have this function 10xy over 2x squared plus 3y squared, this is the graph of this function. Okay, here if I come to this function from the line y equal to x, like this one, then the limit goes to, if I choose the path through the line y equal to x, then the limit is equal to 2. If I choose the line y equal to minus 0.7x, then the limit is equal to minus 2. But if I choose another path, this one, y is equal to 0.4x, then the limit is equal to 1.6. So I have different limit when I change different path. So we said that this limit does not exist. This limit does not exist. Why? Because I come to the same point from different paths, but in all cases the limit are different, so the limit does not exist. To be exist, so the limit should be equal if I same number if I come to the point from any direction. The properties of limit for the two function is similar to that for the one function, which means that if I have a constant multiplied by the function, then the constant can become outside from the limits. If I calculate the limit, this is the addition property. If I calculate the limit of the summation of two functions, then this will be equal to the limit for the first function plus the limit for the second function. And this is the limit for the product. If I have a product of two functions, then the limit for the product of two functions is equal to the limit for the first function multiplied by the limit for the second function. Same for division. The limit of f of x y over g x y is equal to the limit of f of x y over the limit of g of x and y. So the properties for the limit for the two variable function is similar to the properties of the limit for one function. Let us go for this example. I need to calculate the limit for this function xy squared plus x cubed y plus 5 when xy goes to minus 1 0. So the easiest way is to substitute. You need to substitute. X will be replaced by minus 1, y will be replaced by 0. So minus 1 by 0, because x and y goes to minus 1 to 0. So substitute x by minus 1, substitute y by 0. So here we have minus 1, 0 plus x cubed, which is minus 1 cubed multiplied by 0, y is equal to 0 plus 5. So this one 0 plus 0 plus 5, which is equal to 5. So the limit for this function is equal to 5. Similar here, if I need to calculate the limit for this function, I will substitute x equal to 3, y equal to 4, because we need to calculate the limit when x, y goes to 3 and 4. So first, direct substitution, you need to calculate the x by 3, replace the x or substitute x by 3, substitute the value of y by 4. So here we will have 3 minus 4. 3 minus 4 over 3 square plus 4 square, which is equal to 3 minus 4 is equal to minus 1 over 3 square plus 4 square, which is equal to 9 plus 16, which is 25. Square root of 25 is 5. Square root of 25 is 5. So the answer is minus 1 over 5. How we calculate the answer? We go for direct substitution. So the limit from any direction is equal to minus 1 over 5. So we say that the limit exists and it equal to this number. Okay, I need to calculate here the limit for x square minus 1 y square minus 4 over x minus 1 y minus 2. So when x y goes to 1 and 2, so I will go for the first direct substitution. I will replace x by 1, y by 2, x by 1, y by 2. So x square minus 1 will be 1 minus 1. X square minus 1 will be equal to 1 minus 1. Y square minus 4 is equal to 4 minus 4, because y is equal to 2. 2 square is 4. Over 1 minus 1 over 2 minus 2. So when we calculate, 1 minus 1 here is 0. So 4 minus 4 is also 0. So the answer here is 0 over 0. 1 minus 1, 2 minus 2. So we have 0 over 0. 0 over 0. So here we have 0 over 0. So in this case we have this is not mean that the limit does not exist. We need to find another way to find the limit. The direct substitution is fail here to find the limit, so we need to find another way. Usually if we have one function variable, we go for Hopital rules, but here we cannot apply Hopital rules because we have two variables. If I have one variable, I can apply Hopital rules because we will calculate the derivative with respect to this variable. But here I have two variables, x and y. I cannot apply Hopital rules. So I need to find another way. Usually when you have 0 over 0, which means that we have sometimes we have a common factors between the numerator and denominator. So here I will go for x square minus 1. I will analyze this one to two factors. So this one, x square minus 1, this is a difference between two squares, which means it is equal to x minus 1 multiplied by x plus 1. X minus 1 multiplied by x plus 1. And y squared minus 4 also can be analyzed, which is equal to y minus 2 multiplied by y plus 2, because this is one also is a difference between two squares. So this is a linear factor, we cannot be analyzed. So x minus 1, y minus 2. This one are a linear factor, not a quadratic equation, so we cannot analyze. So here, if you notice, we have a common factor that can be cancelled. X minus 1 can be cancelled with x minus 1. Y minus 2 can be cancelled with y minus 2. So I need to calculate the limit only for x plus 1 here, because x minus 1 from here can be cancelled from this one. Y minus 2 will be cancelled with y minus 2. So only I will calculate the limit for x plus 1 multiplied by y plus 2. So when you calculate the limit, now we can go for direct substitution. When I put x equal to 1, we have 1 plus 1. When I put y equal to 2, we have 2 plus 2, which means 1 plus 1 is 2. 2 plus 2 is 4. 2 times 4 is 8. So the limit is 8. So when we have 0 over 0, this doesn't mean that the limit does not exist. We just can conclude that direct substitution fails to find the limit, so we need to do something. for this function to calculate the limit. Here I cannot apply Hopital rules because I have two variables, x and y. We cannot go for Hopital rules. Usually for function of one variable we go for Hopital rules, but here we couldn't. For multivariable function we couldn't apply Hopital rules. So first thing, we can consider that sometimes we have a common factor between the denominator and numerator. So we will go for analyzing. X squared minus 1 can be analyzed to x minus 1 and x plus 1. Y squared minus 4 can be analyzed to y minus 2 multiplied by y plus 2. So now we have a common factor here that we can eliminate each other. X minus 1 can eliminate with x minus 1 here below. Y minus 2 in the top can be eliminated by y minus 2 below. So we have only x plus 1, y plus 2. So now go for direct substitution. 1 plus 1 multiplied by 2 plus 2, because y is equal to 2, x is equal to 1. So the final answer is 8. Okay, go for this one. This one also direct substitution. We have sine 0, which is 0. Direct substitution give you sine 0 over 0. Sine 0 is 0. So we have 0 over 0. 0 over 0. This is not equal to 0, not equal to infinity or something. So this one means that the limit here, the direct substitution fails to find the limit. So you need to do something or find another way to find the limit. So the limit here, I will make a new variable. Here I cannot analyze anything, so I will go for another trick. So here I will assume that x plus y is equal to any variable t. X plus y is equal to any variable t. So when x and y both goes to 0, 0, this means that t itself also goes to 0. T itself also goes to 0. So here I will calculate the limit for this function. I will change to a new variable t. So when xy goes to 0, 0, which means that t goes to 0, and sine x plus y will be sine t over x plus y here will be changed to t. So I change the function, the limit for multivariable function, or the limit for function of two variables, to limit for function of one variable only. So now direct substitution will give me 0 over 0, but here I can apply Hopital rules because here is a function of one variable only, which is t. So going for Hopital rules, limit when t goes to 0, the derivative of sine is cosine, the derivative of t with respect to t is 1, so cosine t over 1. So now substitution, go cosine 0 is 1, 1 over 1 is 1. So here the trick here, I change the function of two variables to function of one variable. So x plus y will be replaced by t. So now the limit when xy both goes to 0, which means that t also is going to 0. T also is going to 0. Okay, for this example, we need to find or to determine whether or not this limit does not exist or not exist. This is the limit is exist or not exist. So here I ask you to find the limit during the path, during x-axis, during y-axis, and y equal to x squared. So I will find the limit for these three paths. If the limit is different, which means that the limit does not exist. Okay, so first I will calculate the limit when x-axis, through x-axis. The equation for the x-axis is the line y equal to 0. The equation for the x-axis is y equal to 0. So the limit here, when y equal to 0 will be the limit xy goes 0, 0 will become, because the equation now y is equal to 0, so x0 goes to 0 and 0, x0 goes to 0 and 0 because y is equal to 0. Now xy, which means that x will be multiplied by 0 because I chosen the path y equal to 0, x-axis. For all x-axis, y is equal to 0, over x cube plus y cube. Y is 0, which is 0, substitute y by 0, so you will get that x multiplied by 0, which is 0, x cube plus 0, which is x cube, so the final is 0 over any number is 0. Okay, so now here let's use the path x equal to 0, which is y-axis. X equal to 0, the second path we calculated already around x-axis. Now we need to calculate y-axis. The equation for y-axis is x equal to 0. So the limit when 0, y goes to 0 and 0. Now here we have x equal to 0. So I will substitute x by 0. So here we have x by 0, 0 multiplied by y, over 0 plus y cube, so it will be equal to 0 over y cube, which is also equal to 0, because 0 over any number is 0. So here we have the limit through y-axis is 0, through x-axis is also 0. Now the third path is y is equal to x squared. So here we will find the limit through this path. Y is equal to x squared. So we will replace y by x squared. So x times y, which means x multiplied by x squared, over x cube plus y cube. So x squared cube. X multiplied by y here is x squared, over x cube plus y cube, which means x squared cube. So will be the limit for x multiplied by x squared, which is x cube, over x cube plus x squared cube, which is x to the power 6. So I need to calculate the limit. Here I have a function of one variable. So direct substitution 0 over 0, so you need to do something. This one is x cube over x cube plus x to the power 6. We can choose x cube as a common factor. So we have 1 plus, when I x to the power 6, when I divided 8 by x cube, will remain x cube. So x cube between these two terms is a common factor, can be taken outside. So now we have to cancel x cube with x cube here. So we have only to calculate the limit 1 over 1 plus x cube. Now direct substitution with x equal to 0. So we have 1 over 1 plus 0, which is 1. So this means that the limit does not exist, because here the limit through the path y is equal to x squared is different from the path y-axis, is different from the x-axis. Through x-axis is 0, through y-axis is 0, through this path y equal to x squared is 1. Different path, different limit means that limit does not exist. So now we need to explain the continuity of the function. We said that the function f is continuous at the point a, b, if it satisfies two conditions. First condition, the limit at the point exists. Second, the limit equal to the value of the function at this point. This concept is similar to the continuous concept for one function variable. If we go back to the one function variable here, For example, for this one at 2 the limit does not exist, so we have discontinuous at x when equal to. At x equal to, the function is discontinuous. Why? Because the limit does not exist. Also at x equals 0 here, we said that this is not continuous because the limit from the left does not equal to the limit from the right. Here at -1, the limit exists because the limit from the left is equal to the limit from the left is equal to the limit from the right is equal to 3. But the value of -1 itself does not exist. So even though the limit exists, the function is discontinuous at -1 because the value of f -1 does not exist. F -1 does not exist. The limit exists. Right? The limit when x goes to -1 for f of x is equal to 3. But this is not equal to f -1. We have no value for the function at -1. So this is why the function is discontinuous at -1, even though that the limit exists. Here similar, here the limit exists. The limit when I come to the x equal to 4 from the left is equal to the limit from the right. So the limit is exist, but the function discontinuous. Why? Because the value of f4 is 1. The value of f4 is 1, not 3. Not 3. The limit equal to 3, but the value for the function at x equal to 4 is 1. So 1 not equal to 3, so the function is discontinuous. The function is discontinuous at x equal to 4. The limit exists equal to 3, so but the function at 4 is equal to 1. So at x equal 4, the y value of f4 is 1. The y value is 1. But if I calculate the limit as x approaches to 4, from the left and from right, it is the limit equal to 3. The limit equal to 3. So the limit exists equal to 3, but the function is still discontinuous because f4 not equal to 3 is equal to 1. Is equal to 1. So similar concept for two variable function. For two variable function, to say that this function is continuous, the limit should be exist and equal to the value for the function at this point. The limit should be exist and the value of the limit is equal to the value for the function at this point. Let us go for example. I need to calculate the limit for function f. I need to prove that the function ln 2x plus y minus z is continuous at the point 2, 0, minus 1. 2, 0, minus 1. First, we need to calculate the limit at this point. So direct substitution for x equal to 2, y equal to 0, z equal to minus 1. We have ln 2 multiplied by 2 is 4, y is equal to 0, z is minus 1, and have another minus here become plus. So we have ln 5. This is equal to f2, because if I calculate f2 0 minus 1 directly here, it will be also equal to ln 5. So the function is continuous. The limit exists and equal to the value of the function at the point 2, 0, minus 1. So here that we said that the function is continuous. Okay, now I need to prove that this function is discontinuous. Discontinuous means one of the condition is not satisfied. Either the limit does not exist or the limit exists but not equal to the value of the function at 0, 0. So first we need to check if the limit exists or not. If the limit exists or not. This is the function x squared over x squared plus y squared. First I will use x-axis, y goes to 0. Then when I choose y goes to 0, so the limit will be equal to x squared over x squared plus 0. x square over x square plus 0. The limit of xy goes 0 0 become x0 goes to 0 0, because we will substitute y by 0. Y by 0. X square over x square is equal to 1, so the limit will be equal to 1. So through x-axis, the limit for the function equal to 1. Okay, let's check around y-axis. We will use the path y-axis, which means that x will be equal to 0. xy will be goes to 0 and y, or 0 and 0. Okay, now we will substitute x by 0, because through y-axis x is equal to 0. So 0 over 0 plus y square, we have 0 over 0. 0 over 0, which is equal to 0. So the limit through x-axis is 1. The limit through y-axis is 0. So by using two path rule, we can prove that the limit does not exist. We choose the path x-axis, next the second path y-axis. So different path, different limit, which means that limit does not exist. Limit does not exist, so the function is discontinuous because the limit does not exist. Okay, here we need to prove that the function for this one is continuous. That means that we need to prove that the limit exists and the limit should be equal to 0, because the value of the function at this point is equal to 0. So here if I calculate the limit, it is equal to 0 over 0. So direct substitution fails to find the limit. So you need to find another way to find the limit. Hospital rules cannot be applied because multivariable function. So here I will change the equation to polar equation. So x is equal to r cos theta, y is equal to r sin theta. Why? Because at the polar equation r square is equal to x square plus y square. So when x and y goes to 0 and 0, which means that r goes to 0. So here will become the limit when r goes to 0. X square become r square cosine square theta. Y is r sin theta over x square, which is r square cos square theta, plus y square, which is r square sin square theta. So here limit when r goes to 0. Now r cube, r square multiplied by r is r cube. This one, r square multiplied by r is r cube. Cos square theta sin theta, cos square theta sin theta, over, now r square cosine square theta plus r square cosine square theta is r square cosine square plus sine square, which is 1. So r cube over r square here is become r. So we need to calculate the limit when r goes to 0 to r cos square theta sin theta. So direct substitution will give you 0. So the limit is 0, and this one is equal to g00. Why? Because the function at 0 0 is equal to 0. So the limit exists and equal to the function at the same point, at the point. So the g is continuous at 0 and 0. G is continuous at 0 and 0. Okay, now here we need to, this function is not continuous at the origin, but we need to extend the function to make it continuous. This means when we say that extend the function to be continuous, which means that the limit exists, but you need to define the function at the point. We need to define the function at the point, because if the limit does not exist, we cannot extend the function to be continuous. We can do extension to be the continuous only if the limit exists but not equal to the function at this point. So you redefine the function the function at this point. So first we will find the limit. So we have to find the limit at the origin. Xy goes to 0, 0. Ln 3x square minus x square plus y square plus 3y square over x square plus y square. So here direct substitution give you 0 over 0. Direct substitution will give you 0 over 0. So now we need to go for another way to find the limit. So here I will also change this one to the polar function. So x will be r cos theta, y is r sin theta. When xy goes to 0, 0, which means that r goes to 0. So the limit when xy goes to 0, 0 will be r goes to 0 ln. Now this one 3x squared plus 3y squared, which means that 3x squared plus y squared. This term and this term. 3x squared plus 3y squared is 3x squared plus y squared minus x squared y squared over x squared plus y squared over x squared plus y squared. This one is a square. Okay, now 3x squared plus y squared, which means that 3r squared minus x squared here is r squared cosine square theta multiplied by r squared sine square theta multiplied by y squared over x squared plus y squared, which is r squared. Now r squared is a common factor in the three terms that can eliminate each other. So we have ln 3 r squared here will be cancelled with r squared here will be cancelled with r squared here. So 3 minus r squared cos squared sine square theta over 1 This means over 1. So now direct substitution when r equal to 0. So this term goes to 0. So you have ln 3 logarithm of 3. So we find the limit. The limit exists. But now to be continuous, the function at 0, 0 also should be equal to ln 3. So I will redefine this function because f0, 0 here does not exist. f0 and 0 direct does not exist. So I will define the function again. I will say that this function is equal to this value when x, y not equal to 0 and 0. But if x, y equal 0 and 0, the value of function is equal to the natural logarithm of 3. The natural, why? Because the limit here is equal to natural logarithm of 3. So the function at the same point should be also equal to the natural logarithm of 3. Then in this case only the function is continuous. The function is continuous at this point. Similar here for this one. If I go back for this example, this function maybe is not continuous at x equal to 4 because the value of 4 is 1. But when I make the value of 4 is equal to 3, I will change this from 1 to 3. It become continuous. So we can extend the function to become continuous if the limit exists, but the value of the point is different or not exist. Then you define the value of the point again. We can define the value of the point again. So this is what we did here. We found the limit. After we find the limit, we take the value of the limit and we said that the function at this point is equal to the value of the limit to be continuous. By this we already end chapter 6.